Hello, this is Mrs. Dehn-Brastad, and today we're going to go over how to do Chapter 1, Section 5 on using formulas in geometry. A lot of this section should be review from algebra or even middle school math. Alright, so see if you can solve these problems. These are some of the roots and exponents that are required for this section, and then come back and check your answers. Pause the video now. Alright, number 1, 12 squared is 144, 12 times 12. Number 2, 7.6 squared is 57.76. Number 3, the square root of 64, that means what times what equals 64, of course, is 8. Number 4, the square root of 54, is approximately 7.35. That's if you don't simplify the root, if you just use your calculator. Number 5, 28.27, or maybe you left your answer as 9 pi. That would also be fine. And in number 6, watch this one, 88.83, or in number 6 you may have written your answer as 9 pi squared, which would also be correct. So in number 6, you'd take 3 times pi, hit the equal sign, and then square it, or you could square both parts. Square the 3, square the pi, and leave your answer as 9 pi squared, or go ahead and square the pi and then multiply by 9. Alright, so moving on to our objectives for today, we are going to apply formulas for perimeter, area, and circumference of some just real basic geometric shapes. A few vocabulary words to review, and again, you may know most of these: perimeter, area, base, height, diameter, radius, circumference, and pi. And the symbol for pi is that. Okay, the first word is perimeter. Perimeter, we usually use a capital P for, of a plane figure is the sum of the side lengths of the figure. In other words, in order to find the perimeter of something, you would add up all sides. We don't usually write a real specific formula for perimeter because you always just add up all the side lengths. The area of a plane figure is the number of non-overlapping square units of a given size that exactly cover the figure. That's the definition. If we're looking for the area of a figure, we are looking for what would it take to fill in all of this. How many square units does this cover? When you do perimeter, like if you were finding the perimeter of a four-sided figure and each side was given in inches, then your answer would be something inches. If you are finding the perimeter of a four-sided figure and your, let's see, your dimensions again are in inches, your answer will be something inches squared when you're done. So it's important to remember that when you're labeling your figure. Here's some basic formulas for perimeter and area of a rectangle, a square, and a triangle. Put these in your notes, make sure that you know them. The perimeter of a rectangle, again, you could just add up all the sides, or you could say 2 times L plus 2 times W, or you could even write 2 times parentheses L plus W. So you could add the length and width together and then multiply by 2. The area is just length times width. In a square, you could just use the same formulas as for a rectangle because a square really is just a special rectangle. Or you can make it simpler on yourself and multiply 4 times the side length, and for the area take the side length squared. In a triangle, for the perimeter, you will just add all 3 sides up. For the area, you will either take 1/2 base times height or base times height divided by 2. They give you the same answer. Notice that the height is perpendicular, is at right angles to the base. That's the height. The base can be any side of a triangle, but the height is a segment from a vertex that forms a right angle, like I just showed you. The height may be a side of the triangle. It's only a side of the triangle if it's a right triangle. So if you have a right triangle, then this can be the height. In any other kind of triangle, the height has to be at right angles to the base. So that would be the height in this one. here's an example of a right triangle, and there's some other ways that your triangles could look. The video is cutting off this base a little bit. This is B, B, and B. Perimeter is expressed in linear units, such as inches or meters. Area is expressed in square units. Here's our first example. Find the perimeter and area of each figure. See the congruent marks on here? We've got 4 on this side, and this side are congruent, so we know that this is also 4. We know that this is also 6. I would fill those in to start with. The perimeter is 2 times L plus 2 times W, or you can just add them all up. Either way, you should get 20 inches for that one. The area is length times width, so 24. Note the units. For perimeter, we say 20 inches. For area, we say 20 inches squared. Simple enough. Here is a triangle, and you'll see this time we have to use some algebra. So, perimeter of a triangle is you just add up all the sides. So x plus 4 plus 6 plus 5x. Then we would combine our like terms. We have 1x plus 5x, which is 6x, and 4 plus 6 is 10. We don't really need the parentheses here, so you could drop them. This one will just be an expression. And we don't have any units on here, so we can't say inches or meters or anything. For area, we're going to take 1/2 base times height. The base, we could pick any side to be the base. We could pick the 6, which I probably would. We could pick the x plus 4 as the base, because then 6 could be the height. If I did 5x as the base, I would have to find the height as being right angles to that, and I don't know that. So I wouldn't pick 5x to be the base, but you could do either of the other ones. Let's do 6 as the base, and this is the height. I think that's what most people would probably pick. So then we would have 1/2 6 times x plus 4. Be careful with that a little bit. If you do this part first, 1/2 of 6, then you would get 3, because 1/2 of 6 is 3, times x plus 4. And then you still have to do the distributive property. 3x plus 3 times 4 is 12. That's probably how most people would do that one. Remember that 1/2 is the same as dividing by 2. Okay, this one says find the perimeter and area of a square with a side of 3.5 inches. There's no sketch, so I would add a sketch. Remember, a square has 4 congruent sides and 4 right angles. And each of these is 3.5. So the perimeter is found by taking 3.5 plus 3.5 plus 3.5 plus 3.5 if you want, or you could just take 4 times that. And we would get 14 inches. The area is equal to that side length squared. So 3.5 squared is 12.25 inches squared. Alright, here's an example of a word problem. The Queen's quilt block includes 12 blue triangles. The base and height of each triangle are about 4 inches. I'm not going to try to draw all 12, but I'll just draw one of them. It doesn't say if it's a right triangle or what, but I do know that the base is 4 and that the height is 4. So I'll just do that. And we have to find the approximate amount of fabric. Are they looking for perimeter or area? Amount of fabric would be how much you would include in all of this. So that would be area. Alright, so we need to find the area of one of those triangles, and then we have 12 of them. So here's how to find the area of one triangle. 1/2 base times height would be 1/2 4 times 4, or 8. But we have more than one of them, we have 12 of them. So then you would take 12 times that area. Note again that the unit, because we're looking at area, is inches squared. Here's another example. This time we're using rectangles to make our quilt. Or maybe it's not a quilt, it's just fabric again though. And there's going to be 4 of them, but they're all the same. Each rectangle has a length of 6.5. I'm going to write that as 6.5. And a width of 2.5 or 2.5. So know how I drew a sketch right away. That's going to help me keep this straight. If they're looking for amount of fabric, they're looking for area. So we need to find the area of one of those rectangles by multiplying length times width, and that ends up being 16 1/4, or if you had changed it to a decimal like I did, you might have got 16.25. And since our units are in inches, it would be inches squared. And there's 4 of them, so then you would multiply that answer by 4 to get 65 inches squared. All right, let's move on to circles. In a circle, let's sketch a circle here. We have a center, and the diameter will go be a straight line through the center. That is our diameter. And the endpoints are on the circle. A radius goes from the center to the edge of the circle. So it goes from the center and a point on the circle, and that's the radius. The circumference goes all the way around that circle. So that's the circumference. Their sketch is a little prettier. Shows the diameter, the radius in red, and the circumference goes all the way around the circle. They drew the circumference out in a straight line because if you think about this as being a wheel, and your wheel is traveling, here's a spot on your wheel, and you're driving it around, it will trace out a straight line, and that's your circumference. There's formulas here for circumference and area of a circle. Circumference, you can either use pi times diameter or 2 times pi times the radius, because the diameter is twice the radius. So both of these formulas really give you the exact same thing. The area of a circle is given by pi times the radius squared. You have to square the radius first, and then multiply by pi. Otherwise you won't get the right answer. There is a pi. They explain a little bit more about pi. The approximation of pi is 3.14, or you could even use 22/7. You will most likely have a pi button on your calculator that will be even more accurate than 3.14. It's an irrational number, which means it goes on and on and on forever. So we'll talk about pi later in this book as well, in this year. All right, so here's a problem that says find the circumference and area of a circle with a radius of 8 centimeters. And they ask us to use pi on your calculator. That'll be more accurate. So circumference is given by 2 times pi times radius. So we plug in that 8 is the radius, and we can get 16 pi as an exact answer, but they want us to round to the nearest tenth. So then we'll take 16 times pi on your calculator, and you will get approximately 50.3. That's been rounded to the nearest tenth already. When you find the area, you use the formula pi times radius squared. Now remember that you have to square the radius first, so you'll get 64 when you take 8 squared, and then you multiply that by pi. That gives you a decimal number, and when we round to the nearest tenth, we get 201.1 centimeters squared. Here's another one. This time, the radius is 14 meters. So the circumference is 2 pi r. So 2 times pi times 14 is 28 pi. That's our exact answer if they ever ask for it. But they ask us to round in our last one, so we'll do that again, and we get 88.0. Now that might look funny, but we know that if we write the point 0 that we have actually rounded it to the nearest tenth as they ask us to. I'm just going to do that on my calculator quick. 28 pi times pi. Sometimes it might take a little bit of searching to find your pi button, and your pi button you might have to push a second or shift to get to it. So I got 87.9645. Well, that rounds to 88, but again, if you round that to 88.0, then we know that you've actually rounded to the nearest tenth. You could just write your answer as 88 for this class, though. And then area is pi r squared, so we'll square 14 and then multiply by pi, so the exact answer would be 196 pi meters squared, or rounded would be 615.8 meters squared. Okay. Okay, see if you can complete these problems using the skills we have learned today, and then pause the video while you're working on your own paper, and then come back and check your work. Okay, for number 1, you should have got that the perimeter is x squared plus 4x and that the area is equal to 4x plus 8. Let's look at that perimeter one for a minute. We know that we are supposed to be taking, or maybe I have those two backwards. This is area, sorry, and this is perimeter. The perimeter would be this plus this plus this plus this, or we can use the formula which says the perimeter is equal to 2 times the length of x plus 4 plus 2 times the width, which is x. And then when we simplify, we will get 2x plus 8 using the distributive property plus 2x. So you'll see we'll get 4x plus 8 for the perimeter. For the area, we are going to take x times x plus 4, and we have to use the distributive property again, but x times x is x squared, x times 4 is 4x, so there's the area. In number 2, perimeter is 4.8 times how many sides are there? 1, 2, 3, 4, and the area is equal to 4.8 squared. So you do the math there with your calculator, and you find that you get, cover this up a little bit, the area is 23.04 centimeters squared, and the perimeter is 19.2 centimeters. In number 3, the perimeter is just add them all up in whatever order you like. Combine your like terms, and you should get 4x plus 16. The area is equal to the base, looks like that is 10, times the height, which is perpendicular, and then we have to divide that by 2, or you can take 1/2 base times height. So we should get for the area 10x, and for the base, or for the perimeter, 4x plus 16. To finish this area one off, you could multiply on top and get 20x divided by 2, and then 20 divided by 2 is 10x. Or you could have noticed that the 2 and the 2 here would cancel, which would then give you 10x as well. Okay, now let's do a little bit of work with circles here. In number 4, you're going to find the circumference and the area. And in the same thing for these ones. Do note that in number 5, the diameter is 12, which means the radius will be 6. You'll need that for the area. So do number 4 and 5, and then we'll do number 6 together. Okay, so in number 4, you should have got that the area, oh, here's the area here. I think this answer is wrong. The circumference for number 4 would be 2 pi r, which is 2. So you would get the circumference is 4 pi, but not squared. See, they made a mistake here. And the area would be pi times r squared, which is 4 pi centimeters squared. This was the area. Number 5, I'm going to change, I can leave the diameter as it is for the circumference because I could use the formula pi times diameter, which is 12 pi. And for the area, I would change, I need the radius then, so that would be pi r squared, or 36 pi. Now notice that the direction said to leave the answer in terms of pi. That's why I'm not multiplying it on a calculator. And there's the answers again. They have the this wrong again though with the units. This is supposed to be the squared and this one's not. That shouldn't be squared. That shouldn't be squared. Oh, they just put the, I see what they did. They have the square on the wrong part instead of on the. So in number 4, it should be 4 pi centimeters squared for the area and 4 pi centimeters for the circumference. In number 5, it should be 36 pi feet squared for the area, and the circumference should be just 12 pi feet. All right, Number 6, I said we do together. This one says the area of a rectangle. They're giving us the area. That's a little different than what we've done so far. The length is 12.9, but we don't know the width. So what we're going to do is write the formula for area of a rectangle, which is length times width, and then we'll plug in what we know. We know that the area is 74.82. We know that the length is 12.9. We don't know W, so I just write W. And then I'll solve by dividing both sides by 12.9. And when you... Whoops. I'm going to go back to that last page for us here. And when we do that, we get 5.8 for an answer when you take 74.82 divided by 12.9. And that ends our lesson for today. Thank you very much.